getting to space is inefficient. A lot of fuel is used to bring a small amount of payload to low Earth orbit. For example, let's look at one of the most commonly used rockets for bringing payloads to orbit, the Falcon 9. This rocket uses 488,000 kilograms of fuel to bring only 22,800 kilograms of payload to low Earth orbit. That is 21 kilograms of fuel for only 1 kilogram of payload. This makes it hard to build bases on other planets. If you want to build something like a Mars colony, you need food, water, a nuclear reactor and fuel for the reactor, a large ship to go to Mars, the actual base, oxygen, life support, and a lot of fuel for the trip there and maybe back. Right now, using rockets, it would take far too much to get all of that to Earth orbit and to Mars. Because of all of the valuable resources in space, it would be very good for humanity to have a better system to get to Earth orbit. One of the most talked about solutions for this is a space elevator. But there is an even better solution to this problem that does not require new materials or to bend laws of physics. This is a solution we could implement today that has been tested in orbit successfully before at the fraction of the cost and time commitment as building a space elevator. The Skyhook. A skyhook is really just a rope with a weight on one end, or a tether. The idea is we put a spinning tether in Earth orbit, hundreds of kilometers long, and make sure at the closest point to Earth's surface it is just above the point where air resistance is negligible. A spacecraft could get just above the atmosphere and dock to the skyhook, and then be slingshotted all the way to orbit or leave orbit entirely. The skyhook is something called a momentum exchange tether. A momentum exchange tether is in some ways a battery for acceleration. As it spins, the spacecraft on one end and the weight on the other is accelerated by the centrifugal force. When a spacecraft is released at the top of the skyhook's arc, that centrifugal force is exchanged to the spacecraft, and that force becomes acceleration, also decelerating the skyhook's orbital velocity. This could also be used in reverse. When a spacecraft is coming back to Earth, the skyhook could catch the spacecraft coming in, and this would allow for spacecraft coming back to Earth to not need to use chemical engines to decelerate on the way back. It would also increase the skyhook's orbital speed. The skyhook decelerating could become a problem if the skyhook gets decelerated enough to no longer be able to stay in orbit. There are two ways to fix this. The first is we just have some chemical or electrical rocket engines to spin up the skyhook again, or we could use the spacecraft coming back to Earth to accelerate the skyhook. If we had two skyhooks, one around Earth and one around Mars, the outgoing ships from Earth would recharge the Mars skyhook, and then Mars could throw out more, recharging the Earth skyhook. This would allow easy travel between the two planets. There are issues with space junk because if the skyhook's tether is struck by a piece of space junk, it could break up. This can be solved by using a layered carbon fiber around the tether to protect it. We could also just clean up space junk in orbit. Doing that would be a lot easier with a skyhook. Once we do build a skyhook, space travel will be much easier at scale. For example, a trip to Mars would take only 3 months instead of 9, and the rockets could be 84 to 96% smaller if we use a skyhook. Due to how much less fuel would be used to go to somewhere like Mars, much bigger colonies could be set up for less resources. Setting up a permanent settlement in space is important for two reasons. The first is to progress human civilization. Somewhere like the moon is a blank slate, a playground for technological development. The amount of technology coming from a moon colony would be similar to the amount of technology that was developed during the space race. There's also a lot of natural resources out in space, especially in the asteroid belt. The second reason is to preserve human civilization. If some catastrophe on Earth occurred, ending our life on Earth, a colony on the Moon or Mars would ensure that humans survived. If there truly is no life outside of Earth, the extending of Earth's life beyond Earth would ensure that life in the universe did not go extinct. In the more short term, building a skyhook would lower the amount of fuel used for space missions, which would decrease the fossil fuel emissions from space exploration. It would also allow mining the asteroid belt to be economically viable. We can take the spinning skyhook concept further by attaching it to Mars's moon, Phobos. Due to how close Phobos is to Mars, it would be very easy to grab a skyhook attached there. If we made it several thousand kilometers long, that skyhook, a super skyhook, would make it super easy to travel to both the outer and inner planets in the solar system, making it much easier in general to go anywhere in the solar system. As you have seen throughout this video, skyhooks can improve quality of life and space travel both in the present day and in the far future. It could increase the amount of space missions, make asteroid mining economically viable in the modern day, and decrease the fossil fuel emissions from spacecraft launches. In the more long term, it would allow humans to colonize the universe much more easily because of how a Mars skyhook around Phobos would allow easy access to the entire solar system. And right now, today, we do have the technology to build a skyhook. It would still be hard, but we have the technology and people willing to do it. So, why aren't we doing it? Let's build a skyhook today.